backwards. So we did derivatives. Now we're going to do integrals. And we pretty much did this when we learned about natural logs and E and all that other fun stuff. So it shouldn't be that big of a deal. However, we will have to incorporate that absolute value that Mark and I talked about earlier because it does become fairly important. So we're going to talk about some integration using what's called the log rule. Yeah, we're going to talk about those pesky trig functions. So the trig functions we did already were very specific. The bizarreness of taking, let's say, the integral of secant squared, like, so that pops up so much. We're going to talk about the 6 basic trig functions. Okay? Sine, cosine, tangent, you already know, but we'll get the other ones too. You should be able to balance a checkbook.
I don't remember that.
I can't do that.
Do you know what a checkbook is? Do you know what a check is?
Yeah.
Just wanted to make sure. It's fine.
That was even worse.
I'm sorry, what?
No, the second people.
That's a poker
No,
deck.
thanks.
Poker decks? Because it ends in an X. Right? Poker decks. Like a Rolodex, but with poker. It has nothing to do with a checkbook. Okay, you just wanted to bring in Pokemon there? Yeah. Excellent, good job. Okay, so we know this already.
I said what?
And we've been using this guy. So u prime over u allows us to take the derivative. So, of course, one of the basic things we learned when we learned integrals is that integration is just the opposite of derivatives. That's why it's frequently called anti-derivatives. Pretty clever, huh? Yeah. So we got that guy. We did problem number 1 when we started the lesson in 5.1. The tricky part, though, now is we got to include that absolute value. It is needed. More than likely, we're going to use number 2. But it's the same thing. X's and u's, just one is just x, the other one is another function. So 1 over x cubed, for instance. Oh, no, we can do that. We can do 1 over x cubed. That's just x and negative 3. Some bizarre function. Okay, and that's a common mistake that people make when we get to this. Now, people have a tendency, any function they have that's 1 over something, they just say, well, it's the natural log of that thing. Okay? Like, for instance, I just said 1 over x cubed. What would the integral of 1 over x cubed be? Well, it would just be the natural log of the absolute value of x cubed. No. 1 over x cubed is x to the negative 3, and we know how to do that. So you got to be careful how you set these things up. And we'll do a number of examples so you can get a feel for how this works. Okay, we ready? Just going backwards. So, what's that? And don't overthink it. Are you fixing your sleeve, Raj, or are you raising your hand? No, okay. All right. Just listen out. You saving that for later? Did it just randomly attach to you from somewhere? Yeah. Okay. What is it? Maybe it's a treasure map. It's a treasure map to his new desk for tomorrow. What is it? You're made in China?
Maybe.
What is it? Also a Chinese.
What do you got? Move the 2 out in front, right? So we can do that. And what's the integral of 1 over x? Natural log of, no. There you go, we need absolute value in there.
Do we have to include absolute values all the time?
Yes. Well, I shouldn't say that. No, not all the time. Because what? Yes.
You want the answer like that and natural log.
Let me click once more. 2 questions for you. Number 1, what happened? And number 2, where'd the absolute value go? Greg?
Will you put the 2 back for the exponent for x, since it's squared, it's always going to be positive.
Beautiful. So we no longer need the absolute value, which is exactly what that says in that paragraph. Is it wrong to leave the absolute value on there? No. So my view is better to have it and not need it than to need it and not have it. Okay? So just leave it on there and you don't have to worry about it, but just showing off there. Okay. So, what are you gonna do? Well, what could you try? You could try splitting the fraction. No, that's not gonna work. You could try canceling, because x cubed over x to the fourth is just 1 over. No, that doesn't work, because there's plus signs in it. You cancel the 3. No. What do you do? Yo.
Taking x out of the denominator and then divide both sides. No.
Nope. Let's hear from somebody else. Nobody. All right, Maggie, go.
Quotient
No. It's an integral.
rule. Oh wait,
Oh.
you.
Here you go. U du. What's u?
4x cubed plus 3.
You don't like your answer?
No, x to the no.
You, is it good? That's it? What happened there at the end? You kind of.
X to the
I lost you
4
there.
plus 3x.
X to the fourth plus 3x.
Yes.
Why should you choose that as u?
Because it's got more x's.
Good. Perfect. It's got more x's. So when you take the derivative of something that's got more x's, you'll get fewer x's, and hopefully those fewer x's will cancel with the fewer x's up on top. Will it? It will, because strangely enough, the numerator is the derivative of the denominator. So you would be as she said, x to the fourth plus 3x. The derivative is 4x cubed plus 3. And sure enough, it just becomes a pesky little old u du problem, which happens to terminate as a 1 over u du. What's the integral of 1 over u du?
Natural log of the absolute value.
Beautiful. Plus c, because it's an indefinite integral. Always count on somebody to throw plus c in there. Put the u back in. Can I get that? Do I need the absolute value bars? You bet I do, because that could go negative. Yeah, you betcha. So we'll leave them in there.
Mr. Reed,
Yes.
if they give you a range on an integral, do you not need
A
the
range?
absolute? What's that? Yeah.
A range? Yes.
You probably don't need the absolute value signs, right?
If they were to say,
Like 1 to 4.
yeah,
Yeah.
pick a number less than 1 but greater than 0. Sorry, pick a negative number between 0 and negative 1. Negative 1/4 is going to get smaller, smaller, but yeah, I get it. Rational function, numerator, splitting the fraction may reveal a form that can be elaborate. Okay, let's just do this. Okay, split the fraction. So, when you split the fraction, the denominator stays intact. You only split the numerators. So we get that. Now, notice how I split it up. It's kind of weird. I didn't write it as 3 separate terms. I wrote it as 2 separate terms. I cheated. This isn't a very common practice, but again, it's another weapon for your arsenal while solving mathematical problems. I paired up the x squared plus 1 together so that I could cancel here. That leaves me an x over here, and I get that mess. This won't always work, but it's an option to try. And you'll see that when everything is said and done, it breaks up into a nice little business that we can deal with. Can you find the integral of 1? The answer should be a resounding yes. Good. I got 1 yes. Thank you.
Yes.
Can you find the integral of that? Yeah, because it's similar to the one we just did. The numerator is less than the denominator, and that's the derivative of that, so we'd be good to go. Put that into play. We get that. Split it into 2 integrals. Take the integral of 1 dx. Take the integral of x over x squared plus 1 dx. Solve each of those, add the answers together, and you get where'd my absolute value go? What's the matter, Greg?
Well,
Okay,
You
go
just
ahead.
over it.
Go over it again?
Yeah, I was really lost.
Do you understand how I got this?
Yeah.
So then all I did is take the integral, I turned the integral of this
Oh.
into the integral of that,
Alright, yeah.
and then treated it as two separate integrals. One of them requires a u/du, which I listed over there. Did the whole u/du thing, got to that. So there's a 1/2 out in front because the derivative of x squared plus 1 is 2x. The integral of 1 over u du is the natural log of the absolute value of u. However, I am lacking an absolute value, so we come back to my question, where did the absolute value go? Go.
Since the x is squared, it can't be negative.
It's not just a matter of the x being squared.
But plus 1, 2.
That expression can never be negative, so we don't have to worry about it. We can just drop the absolute value. If you leave it in there, it's not the end of the world. Mary?
I'm just confused, like, so in the second line where it says 1/2 and then the integral of 1 over u du, like, where did the 1 over u come from?
This, when I take the derivative, I would solve this, dx would be equal to 1 over 2x. So the x would cancel with the x up on top. The 1/2 is that 2 moved to the other side, and then x squared plus 1 is u, and you just get 1 over u.
Oh, okay.
Just it's the same u du problems we've been doing all along.
You just-
Yeah, the new stuff comes in on that step.
Oh.
Michael?
On the quiz on Thursdays, it just gonna be derivatives and integrals.
5, 1, 5, 2, yeah. It's all natural log stuff. Patrick?
Why is it parentheses and not absolute value?
Because x squared plus 1 is always a positive value. No matter what you put in for x, you're going to get a positive value. And therefore, we can drop the absolute value. You don't have to. You can leave them in there. It's okay.
So we can just leave it as dx for the first integral.
Yep.
That always goes up front.
Yep. The other thing about it is if you're still struggling with the integrals, like it says here, if you're not sure if your answer is correct, just take the derivative of it. You should end up back where you started because, again, those are inverse functions. Okay, take the derivative, you should get the integral. You take the integral, you should get the derivative. What's it mean to solve a differential equation? Remember, these are the types of problems where I give you dy dx, also known as the integral, and I want you to go back to the original function, which means I need to take the integral of both sides, because if I have the derivative of y and I want y, I have to undo the derivative by taking the integral. Okay, so it turns into that. The integral of the derivative of y is just y, which means I have to take the integral of the right side, and I get that. Now what do? Holy guacamole. Any ideas? Oliver?
Wouldn't y be equal to the natural log of the absolute value of x times the natural log of x?
So you just want to take whatever that thing is over 1 and put it in an absolute value bracket and stick a natural log in front of it.
I don't want to, but it's a way.
It's a possibility. Any other ideas?
Not right now.
No. Anybody else? Okay, so this is what I was talking about before. What happens now that we've introduced this idea is people take any function over 1, any function under 1, and they automatically do exactly what Oliver suggested, which is not going to work all the time. It'll work occasionally, but it doesn't work here. You can't just take that function and say, well, it's the natural log of blah, 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 blah. This is actually a u to u problem. What are our possibilities for u?
X.
Could be x. That would be kind of silly. What else?
Natural logs.
Natural log of x.
I'm 1 over.
Could be 1 over natural log. I mean, there's a lot of possibilities here. Could be x. Could be natural log of x. Could be 1 over the natural log of x. Could be 1 over x. Could be that whole mess there. What works? Dun, 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 that. So I choose the natural log of x to be u. When I do the stuff that we've done all along for u du problems, I get the derivative of natural log of x is 1 over x, which means that dx is equal to x times du. We're used to that being in the denominator and canceling with the numerator. This is flipping it over. Which means now when I substitute, this x from the du is going to cancel with the x that was next to the natural log in the bottom and turns it into this. So let's stop for a second. Does everybody understand how I turn this thing, whoops, this thing into 1 over u? Do I need to review that, or are you good?
That's the x you canceled, the one on the
This is the x I canceled with the du, with the x, dx being equal to u d, x du. Oh, I butchered that.
x.
This is the x I canceled with the x that was in the expression of dx being equal to x times du. Oh, I said it right that time. Okay. Which means that's just u. So this thing becomes 1 over u du, which is how I got that. Integral of 1 over u is the natural log of the absolute value of u. Plug it back in, and we get that weird natural log within a natural log thing. For some bizarre reason, that particular function happens to pop up a lot. I don't know why. So you have two options. You can remember what I did here and do it over and over again, or you can just memorize it. I'm not a big fan of memorizing, but in this case, you might just want to memorize that function. Throw it on a note card, throw it in your stack of things to remember, and that way you know when you come across that, you're good to go. Or do the integral, I don't care. Yes?
Is 5.1 and 5.2 going to be on the final?
I do not believe so. I think our final only covers up through chapter 4. Okay. Now we look at the pesky trig functions we haven't done yet. I'm going to show you how to get one of them. And some of you, like I said, some of you did this on the quiz when you didn't remember the integral of one of the trig functions. You went through this whole derivation. But this is where it comes from. You're not going to have to do this. You're just simply going to remember all the integral trig functions. But this is how you would, or this is the derivation of the integral of tangent. Okay, so I would start by writing it as sine over cosine. No big deal. Now I need to choose a u. I have two options. I can choose the sine of x to be u, or I can choose the cosine of x to be u. And then run with it, which is going to work out nicely because what's the derivative of sine? Cosine. What's the derivative of cosine? Negative sine. So we could pretty much do either one. I used u to be the cosine of x. And again, you don't have to write this down. I'll just show you how it happens, and then I'll give you all the trig things. Okay. So started with that, then chose u to be cosine, which turned, that's kind of a big jump there. Do you see how I would go from this to negative 1 over u? U would be cosine of x, du would be negative sine of x, dx. Divide by the sine, that would cancel with the sign in the numerator here. I put a minus sign out in front and it becomes 1 over u. So it's the opposite of the integral of 1 over u. That thing. Which I know what the integral of 1 over u is. It's the natural log of the absolute value of u. So then working a little bit of magic here, we end up with that. And that's the integral of tangent. That's where it comes from. And you can repeat that process for all the other functions. Cotangent would be cosine over sine. Pick one of them to be u. Go and do it. Secant is 1 over cosine. Well, we did secant already, but all the other ones. So you do get some pretty bizarre integrals here when you start looking at all the other trig values. There they are. There's all 6 of them. Some of them you know already. Some of them you don't. And in fact, the bottom 4 you don't. The other ones we looked at were all special weird ones. My paragraph up here is exactly what I was talking about with the quiz. So for those of you that went through that big long process, you still got the right answer. It was just a pain in the butt to get to that point. You're probably better off just memorizing that theorem. And you'll get better at it as time goes on because you'll practice more and more with it. And to be honest, most of them don't pop up very often. You're not going to see the integral of cosecant very often, or cotangent. A lot of it is the sine, cosine, tangent, but the cofunctions show up every once in a while. Make sure as you're writing them down, you get the signs correct. Some of them have minus signs out in front of them. So weird, some colors just disappear. That's actually in a box. Get my computer over there. See that brown box, just gone. It's like it erases certain colors. It's not right. Pink doesn't show up either. I like pink, it makes a good color. I have to start creating my own boxes.
Pink is like a real color.
Hmm?
Pink is the real color.
It's light red.
Oh. It's not on the spectrum, but like a real pink is a red color.
Reggie did. That's spectrum. What's on there? It's just in between.
It's like a mix between red and white. It's like not on the spectrum.
So if you break it down, you can't go anywhere across to find pink.
But if you're going by Reggie Biff, there's no white either.
Good point. Because white is either the absence of color or the
All, it's all.
combination of all the colors.